this hand, hit Calculate. Instantly, our custom web application crunches the dimensions and outputs a precise material cost. To build this, we rely on 3 core web languages working in tandem: HTML for the structure, CSS for the visual design, and JavaScript for the underlying mathematical logic. First step, open your local code editor and create a single blank text file. We will write the entire application inside this one document. Building this tool demonstrates the fundamental cycle of data handling on the web. We capture raw user data, process it through mathematical formulas, and display the formatted results. Step 1 is building the skeleton. We start with a standard blank HTML document structure. This acts as the foundation where all our specific elements will live. Inside the body tag, we need to add specific input fields to collect the measurements. We set up numeric inputs for the length, the width, the thickness, and the price, plus an input for currency. This flow diagram shows our next critical step, assigning unique ID tags to each of those input fields. By labeling them with IDs like length, width, and price, we establish unique identifiers that our JavaScript will search for later. To guide the user, we also add placeholders within these input tags. This displays faint text inside the empty boxes, indicating exactly which units to enter, like feet or inches. Right now, this raw HTML successfully outlines the data we need, but it stacks the boxes awkwardly on the page. It serves as our skeleton, and now it requires a design layer to turn it into a clean user interface. Step 2 introduces the design. We open a set of style tags up inside the document head to begin transforming the visual layout. We write CSS rules targeting the inputs, expanding them to take up 100% of the available width, adding a light gray border, and giving the primary calculation button a solid blue background with white text. This animation illustrates a common layout problem. Padding forces a box model to expand outwards beyond the screen edge. We fix this by applying the rule box sizing border box. This command recalculates the dimensions and snaps them cleanly back to perfectly fit within our screen boundaries. With those few lines of CSS applied, the clunky skeleton is gone. The raw code now renders as an intuitive, evenly spaced, professional layout, ready for user interaction. Step 3 is adding the brains. At the bottom of our HTML, we open a script tag and define a new function called Calculate. We link this directly to our button, ensuring that the function triggers the exact moment the user clicks it. This split-screen logic map shows how JavaScript captures input. Using HTML IDs as connection wires, it grabs the raw typed value. As that string travels, a parse float filter converts it into a mathematical number, allowing us to run calculations. At this point, we hit a major mathematical failure point. The user entered the slab thickness in inches, but the length and width are processed in feet. This conversion formula visualizes the fix. We actively divide the user's thickness variable by a 12-unit ruler, taking those inches and outputting a standardized feet unit to match the rest of our variables. We have now successfully captured the raw user data, converted the text into numbers, and standardized the physical units. The application is primed for the actual math. Step 4 begins with a safety check. We use an is-not-a-number or is-not-a-number command. If any input fields are left blank, this check halts the calculation entirely and triggers a pop-up alert instructing the user to enter all values. Once the data clears the safety check, we execute the initial volume formula. We multiply the length, the width, and the corrected thickness together to determine the total cubic feet of the slab. Concrete suppliers do not sell by the cubic foot. They use cubic yards. This 3 by 3 by 3 grid represents 27 cubic feet. Watch it consolidate into a single cubic yard block. We achieve this in code by dividing total cubic feet by 27. Next, we multiply those final cubic yards by the specific price per yard variable the user entered, which gives us the total estimated cost of the material. To display this math, we use template literals. These allow us to inject our JavaScript variables directly into a text string. We then push that entire string into a blank HTML element using the inner HTML command. Before it hits the screen, we apply formatting commands. We use toFixed to lock the volume to 2 decimal places, and toLocalString to ensure the final price includes proper commas and currency formatting. JavaScript acts as the active engine here. It takes static inputs, processes the geometry, and formats dynamic answers that humans can easily read. Now we run a live test. Let's input a specific scenario: a concrete slab measuring 10 feet by 10 feet, poured 4 inches thick, with a local material price of $150 per yard. Look at this close-up of our final rendered interface. When we click Calculate, the dynamic output instantly appears in green, correctly displaying a volume of 1.23 cubic yards and a properly formatted cost of $185.19. If we briefly open the developer console in our browser, we can also see our success log quietly verifying the exact variables on the backend. You now have a functional, logic-driven calculator running directly in your browser. From here, open your text file and build upon this foundation by adding your own features, like a button to clear the inputs and start again.